let's wait for another like 1 or 2 minutes. So can you guys hear me?
Yep, hear you loud and clear.
Okay, good. Thank you. Okay, wonderful. So let's start. So this is a lecture and 19. So for the applied optimization class, and for today, so we're gonna talk about two things. So one is the kind of a course review, give a summarize for the whole lecture, for the whole semester. I don't know whether you are realizing that this is the kind of the end of all the lectures. So we pretty much cover everything for the optimizations. Okay, and for the rest of the semester, that would be two things. One is your project. Another is pretty much give you some applications demos. So it's kind of like a seminar to give you. Okay, and there might be one additional homework. So that's it. But for the major content, it's done. Okay, so we covered everything about a applied kind of optimization for this course. Okay. Another thing of this lecture is code review. So I'm trying to give you some instructions how to prepare yourself for the exam 2. Okay, and also I will, kind of give you some reviews or kind of a summarize of the code. Okay, we need for the exam 2. So that will be the two things. So before that, let me just give you some kind of announcement. So we will have the exam for next Monday, correct? Everybody should be aware of that, right?
Yeah, that's when the exam will open, right? And then we have a week to do it.
Exactly. So that's very true. So pretty much that I will post the exam 2 papers on the Blackboard. So just on Monday afternoon, like 5:30. So you can access it from there. It's just like a homework, okay? Just like homework. And you will have about exactly 1 week to complete the exam. But I encourage you to, kind of submit earlier. So for example, you can submit like maybe 1 hour earlier, or that doesn't hurt, right? So, but if you are kind of getting late, then that will be an issue. So probably I suggest you just complete the exam earlier, okay? And also you can have some like kind of a strategy. For example, by Sunday you can submit one version, right? Which is fairly good. And then the next Monday you can submit somehow a kind of a refined version. So that would be a kind of way to avoid any kind of a failures or data, any kind of late. Okay, so that would be it. For the submission, it's more like a homework, just like homework. Okay, you have to submit one PDF and also all the codes. So for this time, for the exam 2, I will give you some like I would say some kind of a sample submissions, so you will know how to submit them. Okay, so that will be the exam 2. Considering that you may have some questions, right, about the coding or about the algorithms. So I will host a kind of office hour before the exam. Okay, so the time will be 2 to 3 next Monday afternoon. So you can join. So we'll use this kind of Zoom link to do that. But if you cannot attend during this kind of time period from 2 to 3, then you can actually email me your question, or we can schedule another kind of appointment, but before the exam, okay? So after the beginning of the exam, for example, after the next Monday, 5:30. So probably I will only reply those questions for clarification. For example, if you think that the problem is not well stated, or there are some kind of a confusion about the problem itself, then I will pretty much answer it. But if you're asking about some algorithms or some kind of how to write some codes, then probably I will not reply. Okay. So I hope that you can prepare yourself during this whole week, and then on next Monday, 2 to 3 p.m., so you can ask questions, or actually during any time before that, you can ask me questions about coding. And the point is that you need to fully prepare yourself, okay, and ask me any questions about the code, okay. So that would be the kind of plan for this. But again, we will have 1 hour for for me to take any questions from you guys, and of course I will share this kind of a link also so that everybody can hear it. I will also kind of summarize them in a kind of a slides, and give you some like a PDF version of the solutions or replies to them. Okay, so hopefully this can resolve some concerns from you. Okay. Then let's come to the first part about our kind of a summary about the whole course content. So this slides, everybody can see the slides, right? By the way.
Yep.
Okay, wonderful. So for this slides, you can see that I listed all the content we covered, right, for the whole semester. And on the, let me just use the laser pointer. So on the very left column, you can see there are pretty much four parts, right? That's actually the 4 different focus area for the optimization problem. So for the first part, right, pretty much we spend like 3 weeks, right, on this. It's called single variables, right, which is it's kind of like a very simple introduction to the optimization problem, right? And it's pretty simple because we only have one variable, right, or one decision variables, so which is very simple. And then we actually extend this kind of a problem, right? Or we make it more complex by adding additional decision variables. Pretty much that we, excuse me. So pretty much that we have multiple variables, right? So something like X, Y, Z, right? We have several variables. So that would be we spend like about 4 weeks trying to, solve the multiple variable optimization problems. And actually we spend a lot of time on this, right? Pretty much, I think 1/3 of our lecture time on this kind of problems, because multi-variable problem is very kind of representative, right? And also this is unconstrained, right? It's somehow relatively simple to solve. And we proposed many algorithms to solve them. After that, we think that we can further increase the kind of a difficulty level, right? So we think that we can add some constraints for the problem, right? So which is very common, right? Because you cannot pick any value for your decision variables. So you have some constraints. So for those kind of a constrained problem, we also have some algorithms, right? Something like interior penalty or exterior penalty, right? So these are kind of methods we talk about. And also we have very, theoretical solutions, right? Which is called KKT condition, correct? So that would be some kind of I would say, necessary conditions for the solution to be optimal, right? This is this is Ket condition considers the constraint problems. So pretty much that constraint problem is a very it's the most standard or kind of the most commonly used optimization problem, right? So at this point, actually, we covers almost all the problems. But at the very last 2 weeks, right, pretty much that previous 3 lectures, we think that our problems can be even more complex, right? So, so pretty much we have 2 ways to increase the complexity. One is we think that the decision variables is not continuous, right? And pretty much that the decisions variables can only take integers or sometimes only 0 and 1, just 2 options. So for such kind of problem, so I would say it's very hard to solve, and we introduced like uh, maybe 6 or 7 different algorithms to tackle these problems, right? But again, this kind of there's no general solutions or methods to solve them because they're pretty hard. Okay, and another way to make it hard is that we can have additional objectives other than a single objective, right? So pretty much that's the last previous lecture, right? We talk about the optimization problem that has many objectives, right? And then we also figure out some ways to solve them. So that would be the whole kind of a big picture of this kind of class, right? We are trying to gradually increase the kind of a complexity or the difficulty of the problem. The more difficult or the kind of considering more aspects, then we're actually approaching the real world problem. Because for real world application or real world problem, so we do have many decision variables. We do have many constraints, and also we do have many kind of objectives, right? And sometimes the decisions is largely limited to some integers. Okay, so that would be the hold on 1 second. There's one student asking questions in the email. Hold on. Jose, is Jose here? Jose, are you here? Probably not. Okay, I will not respond to the email. Okay, so this is a kind of a summary for the course content, right? So we cover this kind of a different on different variety of the optimization problems. So hopefully you can have a flavor of this, okay? Oh, you are there. You just sent me an email, right? So it's not relating to this kind of a class, right?
Yes, it's not related to the class. Sorry.
Okay, that's fine. So I will answer the email later, okay?
Okay, thank you.
Okay, that's fine. So for this summary, it's about the course. And then I kind of organize all the algorithms, all the methods we covered. So hopefully you can take a look. So if let's do some kind of a addition, you can see we have 3 methods for the very simple problem, right? And then we have 5 algorithms to solve the multiple one, and 3 algorithms to solve constraint. And the discrete variable we have 6. So pretty much we have about 15 or something like 15 or 16 different methods, right? So I would say you need to understand all of them, okay? And all of them are required for the exam. So any one of these algorithms could be tested, okay? But there are some exceptions. So if you look at the 3 algorithms that kind of colored as green, right? We have 3 this kind of a brute force, gradient, and local search. So we will not test this kind of things because these 3 methods, they are more problem related. It's not general, so it's not that really useful. So pretty much we will exclude them. But for the rest of this kind of algorithm, we have to understand how to implement them. Okay, so for the exam, I'm not really asking you to tell me what the algorithm looks like, right? So I'm asking for the solutions. I'm asking for numbers. So you have to know how to implement this kind of algorithms in Matlab. So of course, we provide the sample or demos, right? You can actually utilize them. That's totally fine. But you have to know where to find those kind of algorithms. And for the kind of exams, so maybe it's very hard to directly copy some code. You need to understand kind of you have to have some like in-depth understanding of the code so that you can know where to kind of duplicate or where to copy, right? How to implement each of them. I will show you some sample some kind of sample questions later. But pretty much this is all the algorithms we need to understand. Okay. So let's spend like about 10 minutes to introduce each of them, right? How about this? So that we can have some like idea of what this kind of each algorithm looks like, right? Again, for the kind of preparation for the exam, you have to study right later, so you can looking for our sample codes or our previous lecture notes, and then you can have a kind of understanding of this one, right? And after reviewing all the kind of lectures, if you have some questions, just email me. Okay, let's just quickly go through each kind of methods. How about the first one? So what is binary search? Can anyone describe or give a short kind of a very brief summary?
That's where you pretty much given a range, you search throughout the range and try to slowly bring in the range to find, like phase one is finding like kind of a near minimum, and then you continue to analyze and get closer to it.
Yeah, so I think kind of, so binary search is somehow like you have a range, right? So the solution will be within that range. So for each iteration, you will kind of half that range, right? And trying to do such kind of things. So from the implementation wise, you will evaluate the middle, left and right, right? You will evaluate 3 points. And then to say which one is kind of is smaller or is better, then you will pick that kind of a solution as your new optimal solution. And then you will construct another left and right hand of it, right? But the gap is halved. Okay, that is called binary search. So pretty much that you are kind of constructing a way to reduce the search range. Okay. So actually, everybody can unmute yourself. You can directly talk. So I think that may be easier to communicate. It's fine to unmute your kind of this Zoom. For the second algorithm, is called successive parabolic approximation, right? What is this guy?
Isn't that pretty much using quadratic formula?
Yes. So yeah, so I think quadratic is the keyword, right? So the point is that you have a unknown objective function, right? But what you can do is that you can pick 3 kind of points, right? 3 solutions. And then you can evaluate these 3 solutions, right? Because we know a quadratic function can be determined by 3 points, right? Then you can use the kind of 3 evaluated points to fit a quadratic function and assume that this fitted quadratic function is the original function, right? You can assume that they have a very good approximation. And then you can minimize this kind of a fitted quadratic, which is very easy, right? Just you can do some like in the middle of the kind of I would say it's very easy to optimize the quadratic function, right? You just simply take the derivative and then you can get the solution. So the idea is that you will use a quadratic function to approximate the original function, correct? And then simply solve that kind of things, right? After you get one solutions, then you can pick another, kind of 2 solutions, right? Including this newly solutions. Then you have another 3 points. Then you can further construct another quadratic function. You can do another iteration. So the idea is that it's called kind of a repeatedly or successively construct a quadratic function to approximate your original solutions, right? That is called this algorithm. Okay, so I hope you can get a sense of it. Okay, so again, it's impossible for us to use 1 minute to summarize or kind of give very details about algorithm. But I hope that when I talk about this kind of algorithms, you will know or you can understand what I'm talking about. So that's something. If you don't know, then you're in trouble. You have to go back to review the specific lectures and trying to get a sense, right? Trying to have some understanding of this algorithm. Okay, so how about another one, the hybrid one? Hybrid, what is a hybrid?
You do a phase or two of binary search, and then you do the successive parabolic approximation based on that narrowed window.
Correct. I think Dylan have a very concise description of this hybrid, right? So the idea is that you will initially use binary search to locate or pretty much to have a very narrow range of the solution, right? And then you will use your quadratic function or quadratic approximation to approximate that function within this kind of very narrow range. So because your range is very narrow, then you can have a very good approximation, correct? So your hybrid will be kind of a very efficient as a kind of if you incorporate the quadratic approximation into the binary search, right? So this is called hybrid. That's very true, yeah. So, but actually hybrid is not really a specific algorithm. It's kind of like I would say, methodology or philosophy, right? You're trying to combine different algorithms, right? So trying to combine their advantages, right? So hopefully you are combining their advantages. But sometimes if you hybrid some two algorithms, you may combine their cons or their disadvantages, so which is bad. But the hybrid mostly refers to, you're trying to combine two different algorithms. But for here, we are trying to combine binary search with quadratic approximation for that would be the hybrid, right? Good. So this is 3 methods for single variables, right? And then we talk about multiple variables. So for multiple variables, kind of a good thing about it is that we can have a contour plotting, right? So which can give us a visual or kind of visualization about the problem, right? We can have the contour, correct? So everybody should know what is contour, right? So for contour is that you may have 3 or 4 different variables, but you can pick 2 of them, right? Just pick a pair of decision variables, and then you can draw the contours, right? And get a sense of how the functions kind of is changing, right? For the whole design space. Okay, so that would be the, I would say, the easy part for the multi-variable optimization, right? Because you have a very visualized kind of I think it's very easy to understand, right? For the contours. So that would be the advantage for it, and we can visualize our algorithms using the contours, right? We can know what's kind of going on there, right? So again, you need to review how to visualize the kind of contours, visualize this kind of algorithms, right? So at least you need to know how to visualize steep descent gradient, right? You need to draw their kind of path, right? So that would be the minimum requirement for the visualization for this. Okay, let's talk about the first algorithm, kind of Monte Carlo, right? So what is this algorithm?
That's where we take random samples and try to find a minimum within those random samples.
Correct. So it's pretty simple, right? We just randomly generate some samples, and then we can find the kind of the best one, right, among the samples. So it's pretty simple. But also for our class, actually we propose like a 2-stage or kind of 2 iterations for the kind of Monte Carlo, right? So at the first stage or first iteration, we generate samples for a very large design space, right? So pretty much cover all the sample areas, and then we can find the best one for the whole design space. And then for the second stage, we actually narrow our search space, right? So pretty much, for example, our original sample area will be, for example, 1 to 10. Then for our second stage, we can reduce like 10% or even 5% of the excuse me, of the original space, right? So which can be more efficient, correct? So that would be the 2 phase of the Monte Carlo algorithm. Okay. Generally, it's very simple for Monte Carlo. How about marching grid, right? So what is this guy?
You make a 9-point grid, and you choose the smallest value based on the proximity to the you choose the smallest value in that surrounding grid, and then you center the grid over that. So now that defines your new area that you're going to look at the points, and then based on that, you can either move the grid or shrink the size of the grid.
Okay, wonderful. Yeah, I think Dylan and Achana actually mentioned them. And also, I don't know, WLT. So actually they mentioned that core idea of marching grid that you will have a grid, right, of 9 points, correct? So that grid will contains, the corners, edges, and centers, right? 9 points. And then you will figure out which point is the best one. If that point is at the center, so which means you have to reduce the grid size, right? Because there's no way to move the grid. Another option is that if the optimal solution is on the corners or on the edge, then you can, move your center to that specific point, right? Then you can move your grid. So pretty much that 2 things. One is that you will have a grid of 9 points. Second is that you need to decide whether your next grid will be kind of a reduced grid or a moving grid, right? So that would be the idea of marching grid, right? It's wonderful, okay? But again, this is somehow the idea of this algorithm, but you need to know how to implement them, right? At least you can understand the code, okay? And then let's come back to this kind of algorithms. So for the next one, the steeply descent algorithm, right? So what's the idea of this? Do you need me to call your name? Or I can just...
I'm trying to let other people answer, but steepest descent is where we have a function. We generally, you can show it on a contour, but you don't have to. And we're trying to find the minimum from the point we're at. So we find we find the gradient of the equation, and then we take the negative of that gradient at whatever the point is, and we head that direction until it becomes like tangent or almost zero, I would say, if that makes sense. And then we turn 90 degrees and go down again, and we keep going down until we find the minimum.
Yeah, that's I think is that Zachary, right? Is that you?
Yep.
Okay, yes, I think that actually talks about a lot of details about this algorithm. That's very correct. So first of all, the keyword will be lective gradient, right? Because the gradient is the direction you will climb the mountain, but for lective gradient is a kind of direction you will kind of walking down along the function hill, right? So that would be kind of a downhill. We can call it downhill algorithm sometimes, but this is also called steeply descent, right? It's kind of a lective gradient. And then after along that direction, so you need to figure out, where to stop, right, along that direction. So sometimes we call it the best distance, right? So which is the best point means that that point will be the best point along this kind of direction, right? That will be the optimal or the smallest solution along the specific direction. So we call it best distance, right? You can determine that one. And then after you find the best distance along that direction, you can update your current solution to that kind of a specific point, and then repeat this kind of a process, right? Just find the negative search direction or negative gradient, right? And then you determine the distance. So that's somehow 2 steps. Okay, that's very good. So yeah, and also that could give us some explanation from the contour wise, right? So in the contour plot or contour figure, so you can see that the labeled search direction, they are kind of perpendicular, right? So, or as Zachary says that, so for the next search direction, that would be somehow turn left or right, right? 90 degrees or left or right. So that would be the kind of contour explanation for this steepest descent gradient. Again, if you don't know what we are talking about, you are really encouraged to go back to review this kind of lectures, right? Okay, trying to get a sense of this. For the next algorithm, that will be conjugate gradient method, right? Again, let me hold on just 1 second. We have a question from our channel. It says that we only find a local minimum with steepest descent. That's a very good comment. So for this kind of 3 algorithms, the steepest descent, conjugate gradient, Newton's methods. So for all the 3 algorithms, they are local algorithms because all the information is pretty much local, right? We only rely on the local gradient. So because of this, so we can only find the local minimum. So that's local. So if you have some like a global valley or kind of, or another minimum, right? It's far away from the current minimum, then our methods will kind of fail to find that one, okay? So that's a very good comment. So for all this kind of gradient-based methods, they are only locals. But sometimes local is also very good now, okay? Sometimes local is good enough. So also Handler says that the single variable methods are also locals. Correct, that's very good. So pretty much that this for example, binary search or quadratic approximation, they are pretty much local. That's correct. Martin grade is also local. But for Monte Carlo, somehow, if you have a very dense sampling, you can find the kind of global. Okay, so that's because it's, here comes our another idea, right? If you want to have some global information, then you need to have some randomness, okay? So Monte Carlo is one way to generate a lot of samples, right? It can explore a lot of different positions or different locations. So that's the key reason it can find the global, because it will not be stuck within some region, right? It can explore a lot of regions, okay? So, so I think I will give you a lecture on kind of randomized algorithms, so which can find the global. So we can talk about that later. But mostly that for all the algorithms we talk about, they are local. That's a very good comment. Okay. Let's talk about the one we call a conjugate gradient. So what's the core idea of this one? Okay, I'm trying to give some comments, right? So it's pretty much similar to steep descent, right? You at least the frame is same, right? You first find the kind of search direction, right, based on the gradient, and then the second step is trying to determine the best distance, right? The frame for each iteration is same, but the difference is okay, that's fine. So Achana says that she can unmute, but that's fine. So compare with steep descent, the conjugate gradient method is somehow like it has a very cool idea about beta factor, right? So for beta factor is about what? It means that for conjugate methods, it will not only use a current location's gradient, it will also, kind of couple with the previous search direction, right? So for example, our beta, so maybe somehow it's very painful for you to compute the beta bar, right? But generally the beta means the ratio between the kind of the gradient magnitude, okay? So that's the beta. So mostly for beta, its value, the value of beta is mostly in like 5% or 10%, okay? So which means we will utilize 5 or 10% of the previous search directions information, okay? So in that way, we can hopefully, have a better search direction, okay? So sometimes it works, okay, for conjugate gradient, because you couple with previous about 5% of previous search direction, then sometimes it's better, okay? But again, there's no absolute, kind of proven or kind of theoretical guarantee that conjugate gradient is better, okay? You need to try both actually sometimes. So that would be but for conjugate gradient methods, for the implementation, so you have to compute the beta first, okay? So that's the only kind of computing node you have to do this. But for the beta computing, it's relatively simple, right? If you have Matlab, right? Because that's only the ratio of the magnitude of first of the current gradient over the previous gradient, right? So that would be the beta's meaning. Okay, so let's talk about the next one, Newton's method, right? What is Newton's method?
Newton's method uses both the first derivative and the second derivative, or the gradient and the adhesion.
Good, wonderful. So that would be the key idea. So for Newton's method is that we'll not only use the gradient, we'll also use the second order information, the Hanschen matrix, right? So the idea is that the gradient, the elective gradient is the direction we want to search. But for Newton's methods, we actually use the Hanschen matrix to modify that direction a little bit, correct? And the beauty of Newton's method is that if your problem is quadratic, then you can just use one iteration to find the optimal solution, right? Because Newton's method is actually assume that your problem is quadratic. Then you can use the Hanschen matrix to kind of modify your search direction. Then you can directly find the best one, okay? So that's the key idea of this. But again, for the steep descent, conjugate gradient, and Newton's methods, for all three methods, they have the very similar frame, right? So, or they have very similar kind of structures for the implementation, right? So for each iteration, we need 2 steps. Step 1 is trying to find the search direction, correct? Step 2 is trying to determine the best distance along that direction, right? So I think we have some slides to compare this kind of 3 methods, right? I hope that you can take a look at them. So that would be the multiple variable algorithms. And then we move to the constraint problem, right? So for constraint problem, although it's very hard, it's very challenging, but we actually find some easy way to solve it, right? So for example, for interior point, so what is interior point here? Anybody can have idea what is interior point?
That's where you evaluate the best solutions from the inside of the barriers to the outside. Then you kind of find that the best solution is on the barrier.
That's very correct. So interior, from the name, we know that the point, the initial point is actually feasible. It's inside of the feasible region. It's called interior point. And then you are trying to update your kind of, the interior point, trying to update your solution towards a boundary. Because for constraint problem, most likely the optimal solution, kind of lies on the boundary of the constraints, right? So that's why for the interior point, you start from an inner solution, or we call it interior point, and then you're trying to move towards the boundary. But you will never kind of pass the boundary, right? Because we have a kind of a, we call it a barrier, right? Kind of a log barrier or kind of a reciprocal barrier, right? Because when we approach the boundary, we will kind of use additional kind of it's like penalty term, right? Adding to the objective, correct? So we pretty much convert the constraints, right? The boundary of the constraints into a barrier function, so that when the solution is approaching the boundary, then the kind of penalty value is kind of increase, kind of crazily, right? So in that way, we will not really pass the boundary. But when we, gradually, reduce the weight for the barrier, then we actually, gradually approach the boundary, right? So hopefully you can, this kind of, description can record or can kind of give you some refreshment about this methods, right? And then similarly for the exterior point, what is that?
Exterior is kind of like interior, except you evaluate the points from the infeasible region to the feasible, and then you also find that the best solution is on the barrier.
That's cool. That's perfect, right? Pretty much that we start from a exterior point, right? And then we're gradually towards the boundary of that kind of things, right? We're kind of approaching the optimal solution from the outside of the region, where we call exterior. But they have the very similar idea. They just convert their constraints, right, into the objective function, right? By doing so, we actually convert the constraint problem to the unconstrained problem, right? Because we know how to solve unconstrained problem, right? We have so many algorithms. Then, so the key idea is that you're just trying to convert your constraints, right? Either by adding some penalty or adding some barriers to it. So for both methods, they are actually adding some extra term for the objective function. Okay, so that will be the interior and exterior. Again, you can email me to kind of schedule some appointment if you want me to give you some further explanation for this kind of algorithms. Okay, so that also works. But I hope that you can review the lecture first. And then for constraint problem, we actually talk about another key kind of very good theoretical idea, right, about optimization. It's called KKT condition. So KKT condition is essentially, let me just finish this kind of thing. So KKT is actually a set of equations or a set of conditions for the optimal solutions. So if your solutions are optimal, then you have to kind of meet this kind of KKT conditions, okay? And from the other perspective, if we list the KKT condition, and that will form some equations, right? If we solve that kind of KKT condition or KKT equations, then we will directly find the solution, correct? So that would be the KKT conditions, correct? So again, this kind of constraint problem, we also have some kind of algorithms for it. So you can take a look at the codes, okay? Let's move on. So we have moved to the kind of a discrete variables, right? So again, we have talked about 3 of 6 algorithms, but here we only cover, or we only need to know 3 of them. So the first one will be relaxation. So what is relaxation?
It's like when you get to the final answer, you kind of round up or round down, because we don't need some like decimal points. You want whole numbers.
Correct. So that's the key idea, right? So because for discrete variables, the condition, very critical condition is that the decision variable is integer, right? Or 0 and 1. But this kind of problem is very hard to solve. So let's just remove this kind of constraints and just regard this kind of question as a continuous problem, right? Then we can use the previous methods to solve it. after we get some solutions for the continuous problem, then we can round up the solutions, right? For example, you get some like 9.56, something this way, you can directly round up or round down. Sometimes you can get 9 or 10, right? You just need to check a few options, right? Then you can get the solution. So this is called relaxation. Relaxation is mostly very simple, but you need to construct the continuous version first, right? But most likely you will not have this kind of things, right? So that's the kind of limitation for this method. You have to construct the continuous version. Okay. For the another problem is called dynamic programming, right? We talk about this kind of a dynamic programming. We spend a lot of time on them, right? So what's the idea for dynamic programming?
I think dynamic programming is where you solve a bunch of smaller problems and then use the results of those problems to affect the next solution.
Perfect. So that's the key idea of this. So for dynamic programming is that you may have a very huge problem, but you can actually decompose it into many smaller ones, right? You start from very simple, very small problems. You can find their solution easily, right? For example, in our knapsack problem, we can easily find the solutions for if you only have one items or if your kind of capacity is 0, right? So we can easily know this kind of a base kind of some problems. And then when we can gradually increase the problem scale, right? For example, we can add one more items, or we can add one more kilograms to the capacity, right? So the idea is that for the kind of a bigger problem, you can actually reuse the smaller problem solution directly, right? And then you can easily compute, or you can easily construct the solution of the bigger solutions, okay? And the idea over here is why dynamic programming works. Because for smaller problems, you are not really, solve them, many times, right? Because for bigger problems, you may have the same smaller problems, but you only need to solve the smaller problem once, right? And then save the solutions. So you only need to solve it once, right? Then you can save a lot of times, because if you don't use dynamic programming, if you are using kind of a brute force, right, you will evaluate all possibilities. And the most possibilities or most evaluations, they will have very similar small problems. You actually repeatedly solve smaller problems. So that's a key reason for dynamic programming. It can save time, right? Because you just save the solutions, right? You just store the solution. You don't need to solve it repeatedly, okay? So hopefully this is a key idea for you. Let's come to the next one. What is integer linear programming? We don't know, right? Pretty much that we don't know the kind of the core. So that's some algorithm that's we didn't really talk about what algorithm. So because it's somehow very complex. So for us, so we only need to know how to use it, right? So for Matlab or there are many commercial packages, they can solve integer linear programming, correct? So as long as you formulate your problem in a linear programming or integer linear kind of format, right? For example, your objective should be linear, right? So which means that your objective is some kind of a combination of your decision variables, right? That's kind of linear. And also for your constraints, it's also linear, right? So in that case, if all the constraints and objective, they are linear. But the only difficult thing is that your decision will be integers. So for such kind of problem, you can use the commercial packages to solve it, okay? But the challenge here is you have to formulate the problem in the way of integer linear kind of formulation, okay? So that's the only challenge you have to tackle with. So that would be the kind of discrete variables. And then very lastly, right? So I think previous lecture, we talked about how to solve multiple objective optimization problem, right? So we know that multi-objective optimization problem, they may have a very complex structures, right? But we have two ways to solve it, right? One is called weighted sum. So what is weighted sum?
Weighted sum gives each function a particular weight based on how much you want the function to play a role into the desired output.
Cool. So that's the idea, pretty much, right? So the idea is that you may have multiple objective functions, but you can, have a way to sum them together, right? And give each objective some weight, right? So that would be the weighted sum. So, but during the last lecture, we know that if you have a different weight, you will get a different solution, right? Correct?
Yeah.
So, but different weight corresponds to different solutions, but all of them are actually optimal, right? So, which means for multiple objective function or multiple objective optimization problem, they will have a lot of solutions, and all of them are optimal, right? It's called a collection of optimal solutions. So, what's the name or the fancy name for this collection of solutions? What's the name for this? We have a set of optimal solutions, right? What is the fancy name for this?
The frontier.
Correct. That's called
Something.
frontier, right? Yeah. Pareto frontier, right? Pareto is a kind of a mathematician, right? So pretty much he invented this kind of frontier. Correct. So we call it frontier, right? So which means that's a kind of a, at the front of the kind of all the decision variables, right? Because that's the best solution for it. So we create Pareto frontiers, and any solutions in that frontier will be optimal. And you can pick anyone, or depend on some other criteria, you can pick one of the solution from it. Okay. And the second method is called Epsilon Constrain, right? So the idea is pretty much that you convert the objective, right? Convert the second objective into the constraint, right? So the idea is that you have 2 or 3 objectives. You just convert the kind of a third or the second objective into the constraints, right? So that you can come back to the you change the problem into the constraint problem, right? So we can solve it. And but the thing is that you need to pick the threshold for the objective, right? So different threshold means your kind of budget or your understanding of the problem, right? You hope that objective will be within control, then you are fine, right? So epsilon means the kind of a budget or kind of resource for that objective, or in other words means you may have some expectation for the objective, right? You want to, the objective is within some level, right? Okay, so that would be the all algorithm we talk about, right, for the whole semester. So are you guys proud of yourself? We have covered so many, right? Different methods. Yeah. Okay, cool. So if you are kind of confused, then you can go back to trying to review the lectures, right? Or ask me using the email. Okay. So one more thing for you to be more proud is we have implemented a lot of codes, right? So give a guess how many lines we have coded for this class, or you have read.
2,000.
What's that?
2,000.
2,000. Okay. Yeah, very close. So I just kind of give some like counting about this, right? I count all the kind of lines, and it has more than 3,000. lines of codes, at least. Okay, and for your homework, you got more than 1,000. Okay, so pretty much that we have you are kind of exposed to these kind of work and MATLAB codes, right? I hope that at this moment, you should be very confident about MATLAB, right? If not pro, but I mean, you should be very comfortable, right? So I'm confident about this, you guys. So for the kind of exam.
How many questions do you think you're going to be putting on the exam? Because I know on the sample you say, yeah, 4, but more to come. I'm just curious.
It's my current solution will be like 7 or 8, something like this.
Okay.
Yeah, so I think that you will spend about like 2 days, something like this, to solve them. Okay.
Will you be releasing a like a guide for the completed samples? Like, will you be releasing the answers and how to do them and all?
Yes. So for now, I will talk about how to solve them, and then after this lecture, I will also upload the solutions on Blackboard. And also, if you need some other tutorial, yeah, I can give you that. Okay. So for the rest, we have about like 30 minutes. We will do 2 things. One is to solve this kind of 4 questions together. Another one is that I will give you some a summary about all the code we need. Okay, kind of like a code building block. So you can directly refer to some block. For example, if you want to plot something, you can directly jump to that kind of a block and then try to get some code from there. So we have 2 things. Okay, so hopefully by doing so we can have a kind of better idea about the coding. Okay. But before that, let me just do some more kind of explanation. So what kind of codes we need for the exam 2? So for your preparation, you need here 3 things. One is that all the demos, right? I provided, I uploaded on the Blackboard. All the codes, you need to understand it. So you don't need to write it by yourself, but you need to understand what each line, what's the meaning of each line, right? You need to know the purpose of it, okay? You need to know how to modify it. So that will be the kind of the basic requirement. And then for the homework solution, that will be, you have to write by yourself, okay? So that will be the homework solutions. So this is somehow, I think you should be very familiar, right? Because you wrote it by yourself. So I think it's pretty easy to pick up them, right? And then that will be the today's session, okay? We have the sample codes and also the review manual, okay? So how to prepare? So number 1 is we have a several step. So here's my suggestion. So one is that just run all the homework solutions, right? And then just trying to understand each line, okay? Because it's kind of read by yourself, right? It's pretty familiar to you, right? And then you need to run all the lecture demo codes. Just kind of debug. Just run them one line, kind of line by line, right? So let me know if you don't know how to do that. That's really critical. You have to do this, trying to get a sense of it. And again, if not, if you don't understand this kind of codes, you can ask me. Okay, just email me. But you need to before the exam. Okay, after exam there will be no questions for coding, okay? The third kind of a way is that you need to run the codes that I will provide you today. And lastly, that you have to know how to debug, right? Debugging is very important. So let me know if you don't know how to debug, right? Pretty much that you just add some breakpoint, right? And then just run the code line by line to say whether the resulting value is expected or not, right? So that way is called a debug, right? Again, for your exam, during the exam, you are welcome or you are actually encouraged to use Google, okay? Google everything, right? So I don't believe you can find the solution for my exam. So that's why I think Google is, there's no harm to use it, right? Doesn't hurt. But the thing is that, although you cannot Google the solution for my exam, but you can Google some solution for your syntax error or logic error or some other errors you may have, okay? So you are very welcome to use them. So again, this is kind of applied optimization, right? We're not really, so my concern or my expectation is that you can use Matlab to give me the numbers, okay? So that is something like, this is realistic, right? It's kind of a very practical. You just solve the problem, right? No matter what kind of way you are using, okay? Just solve it. Google is a very good way to do it. Okay, even for me, sometimes if I forgot the syntax, if I forgot the usage of some kind of a Matlab function, I just Google it, okay? It's not bad to use Google, which is good, right? That's the way, or that's the meaning of why we wanted to kind of take home, right? We have plenty of resource to complete the exam, okay? But then there's something we cannot do, okay? Something like you cannot collaborate, okay? For example, you cannot ask your classmates to give you some idea or some solutions, which is prohibited. So you cannot do this. And there will be zero tolerance for plagiarism, okay? So I hope that everybody just be serious about this, okay? Let's say if you have some questions, just Google it, right? You cannot really ask for help directly from your classmates. So the point is that you are putting your friends or your classmates in danger, okay? There will be a F for you guys, okay? So just don't do that. You sometimes, again, the exam will be divided into many small problems, okay? So maybe you are not confident for one single problem. That's fine, right? That's only count like several 10 points, right? But if you are kind of doing plagiarism, you will get 0, okay? So that would be very critical thing about this. Try to think about, right? Try to optimize your benefits, right? Just so the action for this kind of a plagiarism is 0. Don't do it. Okay, that would be the optimal solution. Good.
Yeah.
Okay, so the same that I talked too much about this kind of things, right? We have about 10 or minutes about this. So let's try to solve the sample questions. Okay. Does everybody have chance to look at the problem?
Yeah, I looked at it. I don't know about everyone else, but I looked at it.
Okay, so let's try to see the problems. Let's see, I think, where should I put it? Just 1 second. This is our exam 2 samples, right? Okay. So let's look at the first problem, right? So the first problem, let me give you some minutes to say, right? So the problem is fairly simple, right? So we're asked to use the kind of a binary search to solve this problem, right? And for the first problem is trying to visualize, right? Or trying to plot this kind of objective function, right? So the problem is that, can you plot the objective function over this range, right? From 0 to 6, right? Do you know how to do that?
Yes.
Correct? Right? That's wonderful. Everybody knows this. Let me just show you the solution. Let me show you the solution. Just 1 second. we got this kind of things. Okay, so for the problem, again, here's the format for you to follow. So during the exam, you have to generate one file for each problem. Okay, so for example, for question 1, you just have a Q1. This is a .m. This is a file you need to generate for the first question. Okay, and then we have 4 files because we have 4 questions. Okay, so you have to do this so that I can quickly run all the problems. And also that the name of the file should be Q1, Q2, okay? And also the Q is capitalized. Let's look at the code. So the idea is that firstly, let's define the objective, right? So the objective is x cubic minus 6x squared, right? So that would be this. And then we're talking about the plotting, right? So actually I put a plotting at the, kind of this code. So let me just move up to here. So that will be the plotting. So if you look at the plot, right? So we have a figure, and then we generate the range, right? From 0 to 6. And then our sample rate will be 0.1, okay? And then we evaluate all the points. And then we can plot it, right? But for plotting, so probably you need something like this. Okay, you need to do something like this, okay? Let's see if you run it. So this is a solution. You have the x-axis, which is from 0 to 6, and the y, right? This is a curve. Okay, then it's done. So that's that easy, right? So this is how we do the plotting. You just simply plot it. Okay, I don't need like a very fancy plot. Just kind of complete the instruction directly. Okay. You can do, of course, a very fancy one. For example, you can have a X label, Y label, title, and mix the line more like wider or colorful. That's totally fine with me. Or you can have a very simple kind of coding or simple plotting, okay? And then let's come back to the problem. We are asked to, the second problem is that let's use binary search to solve this problem, right? And it says that we don't need to use phase 1, which means we need to skip the phase 1, okay? Do you guys know how to skip the phase 1 of binary search?
Yeah, you do. You set your x as the average of your range. So you'll do 0 plus 6 divided by 2. And then you set your delta x as the difference between the two. So 0 minus 6 divided by 3.
Okay,
or
yeah.
Divided by 2. I saw someone's divided by 3.
Yeah, that's very true. So yeah, I think there are some solution from the chatting room. So basically that if you want to skip the phase 1, so we need to take the middle at the middle of the range, right? At the for the initial point, and then our range or delta x will be the half of this kind of range, right? So that's something like this, right? So I set the initial point at 3 and dx at 3. Again, for your code, you don't need to be a very universal algorithm. So you can solve your problem specifically. For example, you don't need to say, I need to say that what is the x left or x right, and then I use some like formula to solve it. You don't need to do that. Just solve the problems no matter which implementation you want. Okay. So for example, here I simply say x star will be 3. 3. Where does 3 comes from? Because I know that the middle of the range, right, from 0 to 6, that would be 3. So I simply put it here. So again, so there's no need for you to make your code to be very, generalized. Just solve the problem, okay? And simple is best. And then let's come to the algorithm, right? For the algorithm, you can see here, this is a very typical kind of a construction. So first, you need to to say how many iterations you want, right? So then I assign value like 20 to this kind of variables. Okay, that would be the, we have 20 iterations. Then we have a for loop. So if you look at here, we have a for loop. So for the for loop, the idea is we have iteration, right? This is an index, and then from 1 to total iteration. So by doing so, we're actually running 20 iterations. Okay, this is the kind of structure. And then, because we know for binary search, we want to evaluate the middle point, left and right? So that would be the kind of 3 solutions we want to evaluate. And then we plug the 3 solutions into the functions, right? And then we get 3 objectives, right? We want to know which one is the smallest one, right, among the 3. Right? Then we can have this kind of a function. It's called a mean, right? Let me see. Let me just run through it. So this mean is pretty much that we'll find this function. Will find the best one, right? The best one in the index is 2, right? Which means the second is the best one. And then for here, I construct a vector so that I can use the index directly, right? So then, which means our X star is updated to the kind of the middle one, right? And then our DX could be, updated by half, right? Because we can go into the next iterations. So that's done, pretty much that's done. So this is the algorithm, right? So this is how we do the kind of coding, right? So we are actually using for loop to do all the iterations. But for this kind of exam specifically, you need to print out your information, okay? For example, you need to, for the problem, it says that, let me just write here. So for this problem, it says that you need to output, so this is a printout. You need to output all the solutions for 20 iterations, okay? So which means, so you need to, for each iteration, you need to print out something. For example, here, I used, let me see, I used this kind of, how to say that? Okay, let me just, so this code, it says, the solution is something like this, right? So this is a use fprintf to do this, okay? You can use any methods, or you can actually just, maybe you can simply, just remove this kind of semicolon, then you can get some information. No matter what, you need to find the information, right? You need to print out something. For example, here I use this kind of fprintf to do this. Then that would be, it will generate one kind of a, printout, okay? So that would be the solution. And then I can, run the iterations. So this is the output, okay? Right? So this is a way you can generate some solutions or kind of informations for the output. You got it?
Yep.
Cool. So this is for the kind of algorithm. You need to use for loop to run mostly that we need 20 iterations. And then for each iteration, you need to do some algorithm related stuff. And at the end of the iteration, you just print out some information from it, okay? So that's the meaning I say, just print out some solutions for all the iterations, okay? So this is the end for the first question. Again, it seems that we are running out of time. So you are free to go, but I will continue to record this kind of lecture, okay? And I may need extra like 20 minutes about this, okay? About 20 or 30 minutes. So you are okay if you want to leave, and then you can come back later to watch the video, okay? I apologize for this kind of uncontrolled, things. I'm sorry for this, but I will continue to record about like half an hour, okay? You are okay to leave, okay? Okay, bye guys who want to leave, but I will continue to leave, and I hope that some of you can, stay with me so that we can get some like feedback. Okay, let's come to the kind of a second question. So for the second question, that will be a very simple one, right? We want to use the steepest descent to minimize the following kind of a question, right? So this kind of question is, I would say, thank you. Yeah, someone say you want to, yeah, or we can continue this kind of a lecture, okay? So the problem is that we want to minimize this kind of a function, right? It has 4 variables, right? It looks very complex, but if you know how to use steep descent algorithm, then that should be very simple, right? We have this kind of unconstrained problem, right? We have 4 different variables. So the initial point is 1, 2, 3, 4, right? So for this kind of a problem, so how do we implement the steep descent? Any idea?
Do you separate the problem into 2 points? Oh no,
2. So
2 functions. I meant. No,
say that again.
I was asking if you would take the function and somehow separate it into 2 different functions, but I don't know if you could do that.
Wow, that's let me see.
No, just continue on and teach how you were.
That's yeah, this is a good question. Can we do that? So short answer is I should say yes for that one, because you have you can kind of like you can divide them. They are totally unrelated, right? They're kind of 2 unrelated questions. They're adding up together, right? So if you can, for example, if I optimize this guy and get the optimal solution, and then I have another kind of optimal solution for this guy, right? Then I can get the kind of, because both are optimal, then we can get a good solution, right? This is very good for this kind of problem, but generally, no. Because generally you cannot have this kind of very good structure. You can divide the problem into 2 unrelated problem, right? So mostly they are kind of coupled. But for this problem specifically, you can uncouple them, right? Because this is one set of a problem, is another one. So I think that's a very creative idea. I think that's very great. So I think that's good. Again, for the problem in the exam, you can use whatever methods you want, and also creative ideas or creative solution is welcome and will have bonus for it. Okay. Again, I like this. I like your idea. Okay, trying to divide them. But here I will use my way to solve it. Okay. So my way is pretty standard. The idea is that because we want to use a steep descent to solve it, right? Then which means we need to find the gradient first, right? And then pretty much the search direction is the elective gradient, right? So the first idea is that we need to find the gradient. So for the gradient is we have a symbolic kind of a value, right? And then we construct the function, and then we use this kind of a gradient, which is a built-in function from Matlab. Then we can use a kind of a gradient to figure out the gradient of this function, right? So let's say if I add a breakpoint, so this is how we debug, right? I add a breakpoint here and then I run it. So let's say the grad, right, is gradient. It means that we have a vector of 4, right? If you remember that for a objective function, the gradient will be a vector of, the 4 means 4 variables, right? You can see this. And then, so I will use this kind of information later, okay? This is a gradient. So then let's come to the algorithm. So of course, the first one will be the usual one, right? We need to define the objective function first, which is the x1 to something else, right? Which is this guy, you define it. And then we need to pick the initial point, right? That is 1, 2, 3, 4. So this is the initial point. And then here comes our, standard frame, right? We want to do 20 iterations, which is a for loop. And then we, assign 20 for this kind of value to indicate we need 20 iterations. And then for steep descent, the idea is that we have 2 steps. Step 1 is trying to find the gradient, right? Because we already use the symbolic method to figure out the gradient, right? So which is, if you want to take a look, that will be this guy, right? So I directly copy the code here, copy and paste. Okay, this is it's not really automatically, it's done by manually. I manually copy them here. And then this is the first gradient. This is the first element or first kind of a component of that gradient. Okay, and then the second, and then fourth one. So by doing so, I actually compute out the value for that kind of search direction. Okay. And then we can use that search direction, put it into the objective function, right? So this is a kind of the function, right? And then for each one, we use a d times the search direction to play as all the points, right? And then we use f-mean search to determine the best kind of solution, right? The best distance. And you can see here the d best is kind of lective. The reason is that I didn't use the lective for gradient, right? So generally I should put something like put a negative here, right? So, but it's okay. I can use positive one, right? So you know what I'm saying? So I mean, for this kind of thing, so we can actually use something like, I will show later, but I will do some kind of comments later. But generally that this is a way we can use f-mean search to search the d-best, okay? And then we can update the solutions, okay? This x1, 2, 3, 4.
Yep.
This is done for one iteration. And then we can, at the very last of the iteration, we can print out some information, right? For example, here, I print out this kind of, a lot of numbers here, right? This is x1, 2, 3, 4. That's the solution for the one iteration. And again, you need to study how to use fprint, okay? Fprintf. So for fprintf, the idea is that you will have something like this. This is a kind of string. In this string, you will, have something like this. So this kind of, this means that I will have some value, afterwards to replace this guy. For example, here, the first, this kind of means that I will use this kind of value to plug in here. Okay, that's the syntax for this fprintf. So trying to Google how to use it. Okay, if you don't know it. Then we need to run, like, for example, 20 iterations. Then the output will be something like this. Okay, this is something I'm looking for, so that you may have very different, very different output, but you need to have this kind of things, right? These numbers should be correct. Okay, so this is for the second problem, right? So we just use the steepy descent to solve it. So the idea is that you find the gradient first and then search the d best and then update it. Okay, that's the key idea. So you can find this kind of codes from previous lectures. You can easily modify. Hopefully you can do this, okay? I think that you'd better to try to solve the problem by yourself first and to say what is somehow is not really, you don't know it, right? Then you can compare with my solution, okay? So by doing so, you can have some sense of your current, kind of Matlab code level, right? Then you can have some preparation for it. So basically, and I hope that you can solve it by yourself first. Okay, this is a second question. Then come to the third one. So for the third one, you can read the problem. Let's see. So for this problem, again, you are asked to use the fmin_com, right? This is a kind of a Matlab comment, or it's kind of a function that you can directly call to minimize some function. Okay, this is a kind of a constraint problem, right? We have a quadratic objective function, right? Which is simple, but we have a kind of a constraint, right? So this is a constraint. And then, so you are firstly asked to use fmin_com to minimize the function. I should say, please output the solution, right? So I will add something like this. So firstly, output the solution for this one. Then you are asked to plot something, right? So this is kind of visualization. So one thing is that you need to plot the contour of this kind of objective, right? And then the constraint boundary. The constraint boundary pretty much is that you want to plot y equals to x squared plus 1. Okay, that is the boundary. Boundary means that equality. Okay, this is the second plot. A third one will be the solution, the point, right? Because you got the point, then you have to print or plot this kind of a solution. So again, all the three things, they should be combined in a single figure, right? So how do we do that? So the way we do it is by adding a hold down, right? Correct? So hopefully everybody can see. Let's look at this kind of code. This is question 3's code, okay? So let's say firstly, we define the objective function, right? It's a quadratic, right? Very simple quadratic. So look at this quadratic problem. And then where are the constraints, right? Where is the constraint? So the constraint is put at the very bottom, okay? Here's a constraint function. So again, if in your Matlab code, if you want to use some like extra function, then you have to put them at the very bottom, okay? No matter how many functions you have, but you have to put them in the bottom. So that's the syntax for the Matlab code, okay? So you put all the helper function. Helper function means some function you want to call for, okay? So for example, for our constraint, right? This constraint is y, you can see that, the constraint. Let me go back to our problem description, right? See here, the constraint is that x squared plus 1 smaller than 1, right? So pretty much that we want to move this kind of y to the left hand, right? Then that would be the x1 squared plus 1 minus x2, right? Again, please pay attention to this kind of syntax, because in Matlab constraint here, we only need one input, but we have two, right? X and y. So in order to solve this problem, then our original x, y, this kind of two variables, they are actually assembled into the input x, okay? It's a vector now. So which means x1 will be x, x2 will be y. Okay, I hope that you can, you should be very kind of comfortable about this kind of rotation, right? That's something like I assemble them into a vector. Because I want to call this function mycon in the fmin_con, see that? So I use this kind of function in Matlab. I need to solve the problem. Again, you can directly copy this kind of a line, right? And then you just modify the input function and also the constraints. Okay, that's all you need. And also here, this is a kind of initial solution, initial point. You can pick any actually. So by doing so, again, for the fmin_con, the inputs, the function here, the function handle, you cannot directly have an objective function here, because our objective function is defined to have two inputs, right? If you're going to, right, there will be some error, okay? So you cannot have this. So you have to change the input into a kind of vector, okay? So this is a syntax to do that. Again, just be familiar with this kind of way to modify their inputs number, okay? And then let me just run through this code. We can step, right? So after we use this kind of fmin_con, we can directly get a solution. Okay, this is a solution. You can have a quick check on this. And then we can print out it. Okay, so here, let's say we print out the solution. Hold on, what's that? What's that? Okay, this is a solution. It seems very weird. But anyway, then for the second part is pretty much to visualize the problem, right? We just mentioned that we need to plot three things. One is a contour, another one is a constraint boundary, and lastly is the optimal solution, right? So firstly, let's have a figure first. And then I hope that you can directly copy this kind of things, right? Figure and hold on. So that by doing so that all the following comments, they are kind of stacked with each other, okay? You will not lose any plot. And then this is a plot, and so by doing so, I just use f contour, which is very simple, right? You simply pick the objective function, right? We defined here to directly plot it, and this is a plotting range, right? X is -2 to 2, and y is 0 to 4. Okay, then you can have something like this. it's totally fine to have a very sparse contour. Okay, I mean, I don't care about it. So, and then you need to plot the constraint. Again, the constraint is we ask to plot the constraint. The constraint is pretty much a kind of a function, right? Y equals to x squared plus 1. So in the code, what you do is you sample the x, okay, which is from -2 to 2. And the sample rate could be any number. It could be 0.1 or 0.01, something like this. Doesn't matter. And then you can evaluate all the samples and then plot it. Okay, so you can see like something like this. Oh my bad. Should be something here, right? This is a curve you plotted. Okay, this is a constraint. And lastly, that you need to plot the solution. So this is how to plot a single point. Okay, you just plot it here, and then because we are in the problem, we are asked to. Oh, let me just plug here. So in the problem, we're asked to plot the figure in this range, right? X -2 to 2, y is from 0 to 4. So let's come back to the code. Then this is how we set the plot range, okay? And then let's run it. It's done. So the plotting is done, okay? This is what I need. Very simple, very primitive, okay? There's no fancy things, just plot what I needed, okay? That would be the solution for question 3. And then we have a last question, right?
Quick question about that last one. So that F-min-com, is that kind of doing the KKT conditions, like going around it pretty much? Is that like just a different way to do it, or?
So you mean what's the inside of the F-min-com?
Yeah, like what is it mimicking, like compared to what we've done this semester? So we've done interior method.
Let me help you. Very good question. What's the F-min-com right here? So most likely it will use interior point methods. So for example here.
That's what I was wondering since we didn't discuss it before. So.
Yeah. Very good question. So you can. The point is that you can configure which algorithm you want. So for example here, can you look at this kind of code, right? Is that you can have some options. For example, your option about the algorithm, you can have interior point, okay? So pretty much that you can use interior or exterior or many other stuffs, okay?
Okay.
You can help, I would say, you can see F-min-com, that's some way, where is that one? You can Google this guy, okay?
Yeah.
They have a lot of, a bunch of information or different algorithm you can choose from, but by default, it's interior point, okay?
Sounds good, thank you.
So yeah, that'd be a very good question. So for the inside of it, that would be the interior point. So let's come to the very last problem, right? It's again, it's a question to utilize this kind of integer linear programming, right, from Matlab. The problem you can see here, it's a linear program, linear programming problem, right? So the objective is linear, right? Linear means that the objective is a combination of the, the weighted combination of the input, the decision variables, right? This is a linear. And also for the constraint is also linear, right? And other than that, the inputs or the decision variables are positive integers. That's so that's the only requirement. So remember this, right? We need to figure out the objective, the constraints, and the positive integers. I hope that you can have some, you may remember this, right? So do you remember this one? The integer linear programming, this kind of thing, right?
Yeah.
This is for the homework. So the idea is that, right, you need to follow this way to, formulate the problem. So for example, firstly, you need to figure out what is f, right? So for f, pretty much is here, right? The f times x. So f, that would be 3, 4, 5, right? That's the coefficient for each decision variables. And then what is a and b? You can see here, ax is less or equal to b, right? So a, that would be the coefficient for the constraint. So here, if you look at here, for a, we have a, so this is something is different from our lecture, right? Because we have 3 different constraints. Then for each kind of each row or each constraints, we can have 1 row in A. For example, here, the first row will represent the first equation, right? The first equation is -1, -1, and for x3, that will be 0, right? So that's why I put -1, -1, and 0, okay? And for the second constraint, that'll be -1, and x2 is 0. So that's -1, 0, and -1, okay? That's this kind of things. And for the last row, that will be -2, -1. But for x1, that's 0, right? So for this kind of things, the a here is kind of a constraint. That would be 0, -2, -1. Okay, that would be the a. A will be the left side, right? And the b is the right side, right? For the right side will be -3, 5, and -6, right? So that put it here. There's a and b. And because we see that x1 to 3 are positive integers, right? So we hope that the lower boundary will be 0, right? That's the kind of positive meaning, right? And we don't have any upper boundary, right? So in that way, we need to assign a kind of empty set here. That means there's no upper bound. And then for the integer constraint, it basically lists which decision variables are kind of integers, right? So we list 1 to 3, all of them are integers. And then I can use this kind of a function to solve it, okay? This is how we do the solving. And then let's say, for example, we can run here, right? If we can see the solution, it's 3, 2, 1, right? That's the solution and some value. And then you can print out, again, this is f printf. You can use many others. For example, you can directly do something like this, then you can have the solution. Okay, this is another way, very simple way to print out solution. Okay, just doing something like this, right? Then your solution will be output. Okay, so any questions about this one? So that's direct use of the Matlab function. Okay. Cool, right?
Yep.
Oh, I think I still need more time on this.
Will these codes be available to us?
Yeah, sure.
Yeah, they're on Blackboard.
Yeah. I will do that one. But for this one, I haven't uploaded, but I will do that later. Okay. So I may comment them, but this code will be uploaded, of course. You will trying to learn this. Okay. Actually, I also prepared another very good things for you guys. So it's kind of it's called code building block. Essentially, I apologize again. We may need another 20 minutes for this. You are totally okay to leave. Okay. Let's say I prepared some kind of summary for your coding. It's kind of a coding building block. So you can use this kind of things to, complete your exam. So essentially, we covered 4 fundamental sections or fundamental blocks. One is very basic, for example, very basics. So for example, the Matlab syntax, right? How to define a variable, how to define the function, right? How to use the for loop. So that would be the syntax. And also a critical thing is that you need to use the dot product, right? So let me just use a laser pointer. So you need to use, you should be very familiar with the dot product, right? That's some syntax. And also the symbolic operations for grading, right? If you want to find the grading, if you don't want to, figure out the grading by yourself, you can use the symbolic operation for the grading. And also how to print out information. So this means the fprintf, okay? The second part will be visualization. For example, how to plot some points, how to plot straight line, how to plot a curve, how to fill some polygon or kind of a contour, right? So this is some basic plotting. Or you can do some fancy stuff. which is not required actually. So for example, you want to change some color, some line width, or some marker size, or set the limit of x and y, or set the labels and add some legends, or put some hold on. Okay, these are some fancy stuff. It's nice to have. Another tool is for the algorithm. So for the algorithm, I already show you how to do the algorithm, right? So firstly, you need to define the objective function, and then you need to define the constraint function if needed, okay? So you pretty much put the constraint function at the very bottom, right, as a helper function, right? You can call it. And also, after that, you can define your initial point, right? X star, right? That's will be the initial point you need to pick. And then you can do that kind of iteration, right? For the iteration is that for each iteration, you need to know how to update the solutions and then how to print out the solutions. Okay, that would be the things you need. And lastly, that would be the how to use built-in optimization functions, right? So I already show you how to do that, right? Correct? So I create, let me see, I create some Matlab code here. Oh, hold on. This is not nice. So here, I will upload this guy. So let me take a look. It's called kind of a building block. Oh, probably I need to. This code is something like you may need. Let me just get the review larger, okay? Get the font larger. So let me see the it should be 18. That's weird. Anyone knows how to enlarge this?
I think it was already on 18. Try 20, 24.
18 is very huge. It shouldn't be that small. No, that's weird. Anybody knows how? Let's see the font editor. That's very weird. Oh, it's customers. I think that would be the what is this? This should be the this is the editor, right? Oh. What is? Oh my God! Can you bear this kind of a small font?
Yeah, that's fine.
Okay, so so this kind of a building block is actually implement all the things I mentioned in the slides. Okay, it mentions all the kind of basics, realization, and algorithm and MATLAB. Okay, so you just need to take kind of a careful look at each of these and trying to understand. So the minimum requirement is for this. You need to understand each of these. Okay, that's the minimum. And after this, you can jump to the lecture codes, homework codes, and some other stuff. Okay, because these are pretty, I would say, basics. Okay, for example, here, let me just go through them. For the first one, the syntax. So for example, you need to know what it is, right? So for the x equals to, let me see, oh my God. I hate this. But again, let's just bear this kind of very small, very tiny fonts, okay? So here is x equal to 0 and column 0.1, column 2, right? So this is actually defining a, if you look at on the right side, it defining a vector of x, okay? That's a kind of syntax for this, from 0 to 2. And then for the y equals to this guy, so pretty much that I put x into this kind of, right? It's x squared for, and the thing is that this will evaluate all the x in this kind of, in this kind of vector, right? So all the elements will be squared if you look at here. So that's the meaning for this, right? The dot, that's the meaning for dot product, right? or dot kind of this kind of power, right? And then it means that all the operation will be element-wise, okay? Then I defined a function, right? This is how to define the function handle. So I use add x, means it's a function, and then here's the function expression, right? Use x dot a. So you are encouraged, or pretty much that you are kind of required to use a dot operation so that you can enable a lot of fancy stuff. So it's better to have a dot operation for everything, okay? And then for here, I intentionally used a lot of mass computing. For example, this kind of exponential x, this is a log x, this is a sin x, okay? You can have different ways to compute them, and then the output will be something like this, right? That would be also, for all the computing is also a kind of a element-wise. So the built-in function is all element-wise. You can see this, right? So x, for example, 0.01 is kind of computed here, okay? So that would be the basic syntax for the variables. And then this is the if-else, okay? So pretty much here, I assign 2 to a variable a. If a is not equal, here, this means not equal, okay? The wave equal, it means not equal. If it's not equal to 1, then I will print out this guy. Otherwise, I print a is 1, right? So at the current moment, if I run it, so that'll be a is 2, right? So which means a is not 1, okay? And then if I assign 1 here, then let me rerun it, you can see that a is 1 now, right? So that's something we can use if-else to do the computing, okay? This is the if-else loop, or if-else block. So the next one will be the for loop, okay? So for the for loop, we already see this, right? We need to define the total iteration or total repeating number, right? That will be 20, and then for I equal this guy. So if I run it, you can see that I repeat 10 times, correct? Besides for loop, we hope to use something like, sometimes we prefer to use while loop. So for while loop is that you don't know how many iterations you need. So you just put some conditions here. So for example, for value square smaller than 30, right? I don't know how many times I need. So I just run it, right? This is a while. As long as this condition is met, then we can do the following steps. And then after we do following step, we'll reevaluate this condition. If it's not met, then we just break this kind of a loop. Okay, that's at this moment, because we have this kind of condition, then that will be just 6 iterations. Okay, because after 6 is pretty much larger than this guy, right? And you can see here, this is a kind of an AND. This is we have a double AND. It means that we connect the 2 conditions at the same time. Okay, this is called AND. Okay, this is a kind of logic operation. This is which means that both conditions should be met. Okay, that's a while loop. Then comes a dot product, or kind of a dot operation. So here, if you look at this kind of a code, for the x, again, I use this kind of syntax, define a vector of kind of numbers, right, from 0 to 1. And for the y, I also define something like this. And for the x, here is I use mesh grid. So mesh grid is something like I can consider all the x and y, kind of like this is a way which we can evaluate a 3D or evaluate a grid. You remember that we sample some a lot of samples from a grid, right? So it's if you have a x and y, you have 2 variables, then you have to sample the grid. So this is a way mesh grid is trying to sample the grid, and you can see here. And then I can use this kind of things, right? They equals to x something like this. This is a way to evaluate on the grid. And then I got, if you look at the right hand, right? This is if you look at right hand, that will be all the values on the grid. Okay, this is how to do the evaluation over a grid. If we have 2 kind of decision variables. Okay, I hope that you can reuse this kind of things. And then we talk about symbolic operation. So which is question 2, right? we know how to use gradient, use symbolic. Let me open the question 2, right? This is this is huge, my goodness. So here we use symbolic operation, right? Trying to figure out the symbolic gradient, right? So that's how we do this. You can refer to that question. And then very last, that I hope that you can know how to use printf, right? This is a function that you can print out information. So for example here, let me just, you can see here, right? So I print out the which iteration number and also the value. If you look at here, right? This is the way to print out the kind of a very fancy information, right? You can have some each iteration number and also the value you want to print out. Okay, that will be the first part. And for the second part, that will be a visualization. Visualization means trying to plot. So for example, the basics that you need to plot some points, right? So this is this 4 lines, for example, figure, and x equal to 1, y equal to 1, and then you plot. This is a way to plot a single point. So the right hand shows the kind of result, right? You just kind of plot a single point. If you want to print multiple points, that's very similar. You actually put all the x in a vector or the y in another vector and then plot it, right? And then you can have this guy. And here the axis here, it means that I need to set the plot range, right? So 0, 3 will be the x limitation, x range, and another 0, 3 that will be the y limitation. For example, let me just change to 4, so that you can get some idea, right? If I change 0, 4, then our y, you can see that the range is changed from 0, 3 to 0, 4. Okay, so this is a points. How about straight line? If you want print straight line, so which is needed for, this is needed for you to print or for you to plot the solution path, right? Because you want to connect different solution paths. Then one way is that you can plot the because for a straight line you have the starting point and ending point, right? That would be 2 things. So the difference between this guy, the points, and the line plotting, that here you have a kind of a dash point here, right? This kind of dash means that you want to plot this kind of a line. Okay, this kind of is very critical. Using this, you can plot a straight line. Okay, it's connected, these 2 codes. It's these 2 points, they are connected. Okay, and R means red, and the star means the kind of a point type for the start and end point. Okay, so that would be a straight line. For the curve means function, right? So for example, we just plot a constraint boundary, right? That would be a curve. So for the curve, the point is that I have 2 methods to do that. So the first method is that you can have x, right? And then you can directly here you can directly use some mathematical equation, right? X squared, right? And then assign to y. Then you can plot x, y. That would be the first way to plot this kind of a quadratic curve. Another way is you can define the objective function, right? You can define the function. This is a very familiar to us, right? Because sometimes we want to plot the objective. Then that would be a way to do this. You define the function. And then for the y, you are not really using a mathematical equation to that. You are actually using this kind of objective function handle, right? You are evaluating using this kind of function to do that. That's another way to do it. Okay, but they generate the same. If you look at this kind of 2 curves, they are identical, right? Okay, so that would be the this kind of curve plotting. So you can have either way. Okay, that's method 1. This is a method 2. Another is for polygon. Actually, I don't think you need it, but just in case you need it, I put it here. So it's figure and you figure. So this is the coordinates, the x component of the all the x. For example, here I'm trying to plot on the right side. I'm trying to plot a triangle, right? A red triangle. So this is the 3 x coordinates. This is 3 y coordinates for the 3 vertices. Okay, so that of this triangle, and then I set the color as red. Okay, this is a way to fill a triangle. If you want make your plot like a more kind of fancy or better looking, then you can have this kind of things. Again, it doesn't matter. For the exam, you can have very native plotting, or if you just want to entertain or amuse yourself, you can have a very kind of fancy plotting. Totally, both are accepted. Okay. For the second, another one that will be the contour, right? So how to plot the contour? So this is pretty easy. We just use the F contour meaning, right? This kind of a F contour. But the thing is that you need to define a objective function, right? This function should have two inputs, X and Y. Then if you define something like this, then you can directly, put it here. Probably I need to mention one thing is that for your coding, you can have extra Matlab code. For example, here for question 1, you can have question 1, but sometimes if you want to define another file to help you to to complete some question, you are totally fine to create some other files, but just include it in the folder. Okay, you know what I'm talking about. So pretty much that sometimes you may need extra M file to help you, but this shouldn't happen. I think this shouldn't happen. But if you want to do that, you are okay to do that. Okay, so I will make an announcement on this. Okay, that's the extra file. But generally, you only need to use one file to complete one question. That's a general rule. But it's okay to have extra one. For the last visualization will be 3D surface, right? So for example, here I want to plot a kind of a 3D surface. So you can see this is a 3D surface, right? So the idea is that this is the function for that surface is kind of x squared times y squared, right? So that would be the function. Again, if you want to plot a surface, then what you need is that you need to generate a grid, right? Because a surface is a kind of a lot of gradient points, right? You can see here. So I need to use mesh grid to sample all the points within the xy space. Then you can use this kind of xy, and then I define the function like this, and then I can directly use the upper x and y to just plug this xy into the objective function. Then you can get the z, and then this is a common to plot a 3D surface. Okay, you may need this kind of things. Okay, that's how we do 3D plotting. There are some fancy stuff, so you are not required to use them, but it's okay to, for example, if you want to, make your plotting looks better, and that's fine. For example, you need to, I will comment, or I will add some kind of things, how to do, change color, how to set limit, how to add legend, and how to hold on, right? I think during our lectures, we already show how to do them, but I will add more details here later, okay? So that will be the end of the second block. So for the third block, that will be the algorithm, right? So in our kind of algorithm, they have the similar structure, right? Pretty much that you need to run a lot of iterations. So mostly will be 20 iterations. So for that kind of things, you are just refer the examples, right? Refer the samples. For example, here for all samples, actually we are trying to kind of use the, for example here. So we use for loop to do the iterations, and within each iteration we have several steps, right? And trying to update the solution, and finally we print out the solution, right? So this is the meaning of how to define the objective function, how to define the helper function, how to initialization. Initialization means it's not fancy. It's a fancy name to say you just pick some initial values for x star, y star. Okay, that's something like this. And then you do the for loop, right? Try to update. But you need to, for each algorithm, there was a specific way to update a solution, right? And a specific way to, you need to consider how to implement each algorithm. Okay, so that will be the algorithm wise. So I hope that you can refer to the previous lecture and this kind of sample questions. So lastly, I think that will be the MATLAB building function. So for MATLAB building function, again, we need to use just three. Okay, one is fmin search, so which is fairly simple, right? So fmin search, again, because our function is most likely defined as a function with x and y, right? We may have kind of two inputs, right? X and y. So for this kind of x and y, if you want to use fmin search, then you have to assemble x and y into a vector, right? So here, pretty much x1 is x, x2 is y, right? In that way, I can use fmin search, and I give the initial kind of a search point, right? And by doing so, let me just run it. I can get the solution is 0, 1. Okay, so that's the way to use fmin search. The only thing you need to pay attention is this kind of you need to assemble x, y into a vector. Okay, this is how you use it. And the fmin_con and integer and linear programming, we just talk about them, right? So I think that's all for this kind of building block. So I hope that if you need some, during the exam, if you need some information, you can come back to here and try to see whether you can grab some information or not, okay? I would suggest you to try to understand each and every line of this code, and then you can start trying to review your homework and your lecture code. And then that will be a kind of fancy way, or kind of a very complete way to prepare for the exam too. Again, don't be kind of don't panic, okay? Just be confident. So you have 1 week to prepare, or maybe not 1 week. During this 1 week, you can ask me any questions. Just email me, or if you need like kind of a Zoom or kind of a face-to-face communication, just you can email me. We can schedule some appointments. I can give you some kind of tutorial for some coding. Okay, any questions are welcome before the exam. Okay, so I hope that this kind of 1 week will be the week that you will learn a lot of coding if you haven't do this. Okay. Again, so our kind of recitation or kind of QA time will be next Monday, 2 to 3 p.m., right? And during that time, you can ask any questions. I will give you some solutions, okay? So that will be it. So today, I'm so sorry that actually I spent you like about 45 minutes more, right? But I hope that you can get a kind of a very familiar or confident about this kind of exam. Okay, so that's all for today's session. And hold on, let me see. There's some questions.
Do we have lecture next week?
Yeah, that's a very good question. We don't have it. So okay, so yeah, thank you, Dylan. So we don't have lectures. So that would be the total time for you to complete the exam. But again, for the QA time, right? I will do 2 to 3, but if needed, I can extend to 2 to 5, something like this, okay? But we will start at 2 to 3, okay? That will be the kind of a QA time, and you can ask any questions, okay? Yes, so for the lectures, we are done. So there's this lecture is done, so okay. So actually, and also for our kind of lecture, for all the, so Achana is asking, are we done with lecture? I don't, so for the course content, we pretty much complete everything, okay? That will be the course content. And for the remaining lectures, that will be a similar, so kind of a similar. So I will give you some kind of topic related technology or something like this, okay? But you don't need to, it's more like, again, just like a seminar or kind of, I would say workshop, something like this. Just come here to, listen to the kind of cutting edge or some kind of latest information about optimization. But there's nothing new about it because all the algorithm problems are already covered, okay? So I would say informally, or we are done with our lectures. Okay, the rest will be your project and my seminar, or kind of, that's kind of things. Okay.
In those seminars, I'm still struggling with one component of kind of going further with our project, but like before now, we've only worked with functions, whereas now we're going to be working with data and have to turn that data into a function. Will you be going over that?
Maybe you can talk to me about your specific project, because different projects have different ways to model it, right? You may have a lot of data, or you may have just small data, right? So it's very project specific. So we can schedule a appointment. Okay.
Okay. Thank you.
Any other questions? Okay, it seems that everybody is cool. So then, so that'll be all for today. Okay, and enjoy your week. So thanks everyone. And hold on 1 second. There's one more question. Check email I sent you. Okay, that'll be, yeah. Okay, I will do that. Okay, great, wonderful. So let's. Okay, thank you everybody, and I apologize again for this kind of delayed lecture. And enjoy, and hopefully everybody can have full preparation for this. And bye bye.